Welcome to another episode on my Raspberry Pi 2 running Ubuntu Linux as well as the robot operating system ROS, which is a messaging service, and as such it is middleware. It is connected to a serial cable connected to a computer, also connected to network cable for VNC, virtual network computing, and a band cable which leads to this breadboard with some electronics and fischertechnik. And the idea is that using C++ I can get a motor to work, I can get LEDs and a phototransistor to work, and as yet that is not working quite as well as I had hoped by now. I'm getting some kind of the same problems that I used to get with Python, and I didn't equip with Python for this project because I liked C++ more, but more because I couldn't get the issues that I had with Python solved. And now the same thing happens, be it in a different way. I'm getting messages in a strange way not being detected while they are clearly there. So what can be done? Well, actually I can program in Bash, and as such send a simple 1 or 0 towards one of the present parts, LEDs, and this one, the motor and the phototransistor. And I managed to get a nice view on a tablet as well. So let's head over to an Android tablet. This is VNC as well, exactly the same thing that you get to see on the screencast, and with a bit of luck I can get if I manage it. It is moving slowly, the bandwidth is not absolutely great. Unfortunately, and whether this is indeed with the tablet or a problem where it comes to the bandwidth, I'm not quite sure. Even this responds slowly. And let's execute GPIO.txt. So and then something here should happen. Let's try it again. Yep, I see a flash here and a little movement here. So it does work somehow. But as you can see here now, it says after the second time, device or resource busy. So it doesn't work quite as well as I had hoped. Anyway, my intention now is to expand this to everything that is being present in the at the board. So these two LEDs, this LED, maybe getting the phototransistor to work, but honestly I doubt that. But certainly get this motor working. Anyway, let's try to get something to actually do what it should do. So here we are again. Familiar screens, publisher, subscriber, and in the other desktop the possibility to run anything. And yeah, writing source code I should keep on one side. So let's open a tab here and go all the way back to the root directory. No, to the user's root directory. Then what do I have? I have 3 exports, while here are 1, 2, 3 exports. Well, let's add GPIO 25. Am I correct? This is input. And what do I have here? Yeah, it's only output. And this is a motor that is nicely there. So I have then 18, 24 and 25 and 12. Okay. 25 is missing so far. So let's add that one. This one should be 25 then as well. And last one. Wait. This one. So now everything should be working. Okay, let me stay in here with this window, then I can open a new one here. No need to source anything. I just have to go in the user's root directory again and say okay, bash, and now it's time to care for more light. Right, that's better. And then GPIO. Alright, so now this one should move a little, this one should burn for a second, and the other, this one and that one should work as well. Let's see. Oh, right. My mistake. Of course, my mistake, nobody else's. Now it will work, hopefully. Yep, one green LED right here. Right, it seems that only the green LED does work so far. Do I have any connection failures? Not that I can see so far. Yes, I do. I do. Right here. Very important to have a connection in order. So let's see if this red one will function. Yes, it will. Very good. Then I have one here that is for the motor. yeah, it moves a little bit, but this one isn't doing anything right now. Nope, it's not. And that, well, it is functioning exactly the same. So the fischertechnik LED is out of 25 then, assuming that it is indeed 25. Oh wait, it is pin 22. 2, 4, 6, 8. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That would be 24. But if I'm counting the wrong way, that cannot be 25 then. I didn't change anything about that, so I will assume it is 25. Pin 22 then. 2, 4, 6, 8, 10 times 2 is 20, is 22 would it be. Is pin 22 indeed 25? Because that is what matters right now. So once again, the only one not working is this one. So I need to check it out. Alright, I checked with this one. Then pin 22 is indeed GPIO 25. So when I lower the camera a bit, it is obviously that this one, the brown one, goes here, which is pin 22. This wire is via a resistor to ground, which is connected, so that should be all working. And I have a problem with this wire. I'm not quite sure where this should lead. That's probably the output for this one, so I'll have to check that. This one versus a loose wire. Anyway, back to code again. So this one is correct because it is pin 22. So why doesn't it work? Yeah, it does work. I saw it flash. That is good. Once more. Apparently touching wires does help. What I'm not impressed with is the motor, but so be it for now. Yeah, that means that the GPIO is accessible. Very much accessible, so. Then, what's next? If you can read it one way, you can probably read it the other way as well. Then it goes to what I want to do anyway. Which is the fischertechnik. Wait, why doesn't that go? What am I doing wrong, if anything? Oh, you find that this works much quicker than via the tablet, because this is straight on. Yeah, I would say this is straight on the VNC, but the tablet is straight on the VNC as well. So that should not, but oh, Raspberry Pi, of course. Yeah. So let me interrupt myself and I have a timeout connection timeout, I should say. All right. So once again with the tablet, and yeah, that is not good for control. And now it responds very fast with everything. So let me get rid of the lamp for a moment for the lighting, and then I say, all right, this one, and go, and that is very quick now, so that is good. Apparently some connection hiccup can happen. Back with the light, and then here, and of the what was the name again? Control. Now I will assume that motor will be the subscriber. So I have to do it in this way. Go and go. Right. So this works, but this is once again without the data. So new tab to Catkin make. Everything is set okay in the CMake test list, CMake list .text, and in the package XML it is all correct. Oh, that's going from bad to worse actually. Trace back. Invalid message spec. Invalid declaration of header. No kidding. Really? So now I have to wait. I make a new tab. Now I have to oh wait, of course, I have to source first. Is it better? Now I can do it. I should be able to. Yep, that's it. Go to message, then editing message, because to my surprise it tells me that header which I had to do earlier on last time is invalid. Why? I don't know. but it seems to be. So, once again, one message, that is good. What does not exist? Oh? I didn't see this one before. Generating C++. Oh, this looks good. But I have to still wait for the end, for a proper ending. No, it's going. I don't think this is going wrong. This is going right. No. Failed. Ah. Aha. This is a very different thing. This goes to the class. This is about this part. I think the GPIO class was not defined. Aha. But I do have it. Oh wait, I may have made a serious mistake here. Yeah, I make a mistake here. No semicolon, a double quote. And here I need stream.h. Okay, new attempt. Alright, another attempt. But I still have another question. Why, when I go to this header file, is header wrong? Since it was told me to do, basically, in tutorial. Oh, you got to be kidding me. I'm back to square one. Ah, wait. Okay, let me also then eliminate the .h and do again, because here it already says compilation terminated. Go. Failed. Oh, recipe for target failed. And there we go again. Was not declared. GPIO 32 was not declared. Wait a minute, that's something different. So, wait a minute. Line 35. GPIO 32. Oh wait. GPIO 32 is where? And I have to admit 32 is not in line. It's not anywhere in here. So where is 32? It is an output. Oh, that may be 12. Maybe. Yeah, that's a mistake. Of course it is 12. Typos, typos. Compilation terminated again. Motor CPP5, which is where? Well, here of course. No. Wait. There's control and there's motor. And right now in motor, this is line 5, column 16. Yeah, this, yeah, okay. Let's make this a header file. Not sure if it is, but it is possible. Oh no, it's already going wrong. But where? Alright. Yeah. Undefined reference to GPIO class. There we go again with the links. Data H, no such. File or directory. Well, that may be very well possible if I say it is in message. So it should either be smaller than, greater than sign, or I have to give the full path. Then I think I have to give the full path. But this is a source. How to do that? That's a good one. If there is, is there a .h, a header file? I have to put this one. There's an include. And there's only this one. Nothing in here. So I think that's another obstacle. So two obstacles now. Once again, a data.header file that is not found because largely the fact that I had to disable the header file part. So header is not accepted. Apart from that, this is undefined. So I will have to reference to the original source file which I got from my other project, how this is being defined. I think I know how, but I have to be sure. Better be safe than sorry. And once again, time goes fast. And that's it for now. And that's the end of this episode. So slowly getting things via Bash to work. 3 LEDs and the motor. This is not yet. Then some errors in C++ and a mysterious thing in message file. And once again Android, which works a lot better now. So going back here from the Android, and that works kind of. The only one that doesn't work is this one. Nope, the fischertechnik one is not being done. Anyway, it's all centered around the Raspberry Pi, and then attempt for tablets to come in for remote control if things work. Unfortunately, the remote camera is not available, but so be it for now. Thanks for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion, and you can also follow me on Twitter and Instagram. Please be so kind to support the blog by making a small donation via PayPal or Wired. Much appreciated. You can also become a patron and have your name mentioned. Everything is on my website as well, and everything is listed under this video. Thank you for watching. To be continued. Bye bye.